Good morning, everybody, ladies and gentlemen. It's a true pleasure to be here in Tokyo and speak to you. And before we start into the topic, I would like to bring my sincere thanks to our host, Igata-san, not only for hosting us here, but also for trying to translate what I'm speaking here into Japanese. And actually, this brings me right into the middle of my keynote today. The translation you're hearing, done with such elegance and nuance by a human being, is something we would come to expect, I think, from machines in our everyday lives today. And you see this already happening here on the screen already. Whether it's with apps, online tools, or automatic subtitles, we increasingly rely on artificial intelligence to bridge language barriers. But translation is just the beginning. Since the launch of ChatGPT, and this was in late 2022, AI has become something like I would say a global miracle cure, a technology surrounded by both fascination and a lot of expectations. Hardly a day goes by today without bold prediction of what AI will do, what AI will disrupt, or what AI will revolutionize. And what I want to do today is bring this conversation a little bit more down to the ground. And especially how AI is finding its way into industry and especially into industrial automation, or even more specifically into electrical design. Before we take a closer look at what AI can mean for industrial automation, I would like to briefly introduce the Friedhelm Loh Group and the group of companies we are representing here. Eplan, as you might know, provides software and services solutions in the fields of electrical and automation engineering. The company develops one of the world's leading design software solutions for machine and panel builders. Both standardized as well as individualized integrations to ERP and PLM/PDM systems ensure data consistency along the whole value chain. Working with Eplan means boundless communication across all engineering disciplines, no matter if it's small companies or big companies. Customers can apply their expertise more efficiently and work seamlessly in electrical engineering. Worldwide, we are supporting a little bit more than 73,000 customers, and we were being founded more or less 41 years ago now, in 1984, and exactly 30 years later, EPLAN Japan was founded in 2014, and now we have a team of 20 dedicated employees operating from 3 locations in Japan: Tokyo, Osaka, and Nagoya. So we are really proud to bring that our software has become one of the, I would say, standards in electrical engineering over the last 40 years, and an epitome for global standards across all industries. And Eplan and Rittal, and now I have to see if I can switch over here. Yeah, Eplan and Rittal are part of the owner-operated Friedhelm Loh Group. So it belongs to one person, which is named Friedhelm Loh. So this is his name. He's still alive and kicking. He's turning 79 this year. And all these companies here belong to his group of companies. And you can see we are operating from with 13 production sites around the globe, 95 international subsidiaries, close to 13,000 employees, and a revenue stake of a little bit north of 3.1 billion USD, or euros in this case. And Rittal, like Eplan, is operating for many, many years in Japan also, and has become a leading global supplier for enclosure systems, automation and infrastructure, as well as cooling in different verticals like industry, the IT sector, but as well as also energy and power, and the services sector. Rittal products and solutions are used also in over 90% of global industries, standardized, customized, and I think one of the key USPs in very good quality. If you ask yourself when this group was founded, it was in 1961, so also not very, very long ago, but still some decades ago. And this is where you can also see the age of our owner. So let me jump into the main section of this keynote speech. My goal today is to provide you, by the end of at least of my presentation, with a realistic perspective on AI, one that moves a little beyond and the hype and the idea as AI as a universal remedy. So secondly, I want to highlight the very real potential that AI applications can unlock, especially for industrial companies like you are representing, including the field of electrical engineering. For example, through our use cases involving the EPLAN Copilot, and finally I will address the key prerequisites needed with the companies, especially when it comes down to data and processes that needs to be there and need to be in place to enable AI-driven decisions. So let me talk a little bit about AI milestones. You know, humanity, and we all, or not, perhaps not we all, but a lot of our society has been talking about AI and artificial intelligence since the mid of the 20th century. So it's also not a new topic, really, frankly speaking. You know, the term was first used, as far as my research belongs, in 1955, and goes back to a project led by John McCarthy at the Dartmouth College in the US, where they were first talking about artificial intelligence. But over the last 70 years, you know, the development of AI has not been a straight path. It has been marked by significant ups and downs, discarded approaches, new starts, and new world efforts. Just as important as theoretical models and algorithms have always been the state of hardware, the performance capabilities of computers, available storage space, and of course the quantity and quality of accessible data. And if you think about this and what has happened over the last couple of years, how much computing power became available on your fingertip by using the cloud, how much data has become available through the cloud also, and the structuring of our processes, this has been a new pivotal point in time on restarting AI. And you know, and AI has always been the result of approaches from computer science shaped by and made possible through the respective developments in hardware and software. And this is, I think, a very interesting example on how hardware and software are going hand in hand, because the theoretical models behind the AI have been there for quite a long time, but the hardware and the computational power was missing. Now the computational power is there. You know, and the models are picking up in complexity. So it's the more computational power you get, the better the models get, and vice versa. And I think one of the key milestones was the immersion of the expert systems. If you remember back in the years in the 80s and the 90s, this were where the first simulation systems came up to the market. And this was something that was theoretically possible, you know, calculating, for example, for the car industry, crash simulations and all these kind of things. Theoretically they were possible, but they were not calculable by humans. And then computational power came up, and out of a sudden, all the calculations behind an FEM model, for example, or a crash simulation were possible because of the new computational power in the hardware. And another, I think, very important milestone then was, and this might be interesting to you also, the development of artificial neural networks in the late 90s, led by Jürgen Schmidhuber, who was at that time the director of the Swiss AI Research Institute. I think this is also something interesting to know. It's not always American, you know. It has been a Swiss thing with the artificial neural networks. And in 1997, they introduced what is called the long short-term memory, which is an interesting phrase, right? A long short-term memory. But this is exactly what is needed to run large language models that were based on this invention at that time. So these were not only milestones, but also, and this is something that unfortunately becomes then very American, billion-dollar investments by the tech giants like Amazon, like Google, like IBM and Microsoft repeatedly led to spectacular demonstrations on what is possible. So think about chess computers beating human chess masters, AI systems winning board games like Go, or quiz shows like Jeopardy. Yet none of these achievements truly brought AI into the mainstream. We all were watching at it, we were fascinated by it, but it never became applicable to what we are doing in our everyday life. But this changed, I think, dramatically in November 2022, when ChatGPT, this ChatGPT service was published officially. Developed by OpenAI, it's based on a large language model which was trained on massive amounts of text. For the first time, even complete novices could interact with AI in natural language. You all know, you can prompt in your language with the model, and the model translates whatever it takes in each language and has in its backyard all the information of which it was trained with in forms of text. And now, I think from this time on, and this is really, I think, a pivotal change in time and AI, is on everyone's lips. Mainstream AI aims to extract the most meaningful response possible from its training data to answer a wide variety of questions. In many areas of human life and work, this already works remarkably well and undoubtedly helpful. I think everybody who's using and trying to use ChatGPT or any other large language model that is trained with a similar amount of information can see how meaningful this can be and how efficient you can get, which does not mean you always get it and you always get the right answer, but at least the extraction of knowledge out of this huge amounts of text and information, I think, is pretty remarkable. Let me talk about a little bit about the Eplan's approach on how to use AI. Our focus really lies especially on the opportunities and potential in the industry. When it comes to supporting creativity, the key question is, how can AI relieve engineers or designers of tasks that can not only be automated but just as well, but even much better and significantly faster? I think we all know in the processes, and we will hear it from the customers, I think, throughout the day, there are many, many processes in place where manual work is still needed, and where we have repeatedly doing the same thing over and over again. And I think this is something interesting where we need to think about on how AI can help in replacing those tasks. I think we are far away from AI really, designing products or really being creative and shaping new ideas. But in helping us to get rid of repetitive tasks and, let me say, bad work, I think this is something where we really need to have a look on. And this is exactly where we as Eplan are looking into. So our mission is to empower electrical engineers with sustainable AI-based solutions that adapt to their specific needs while maintaining the creativity of a human being. Developing these technologies is not a small feat, as you know. It requires deep domain knowledge and precise understanding of customers' environments. But this is where Eplan, I think, excels. And we all know the inconsistency also of AI as you have it available today. You really cannot really trust the answers. Sometimes those systems are really hallucinating and creating funny answers. But think about, you would ask an AI to do a security design for a machine. This would not be enough to know that this design might be right in 90% of all cases. It has to be 100% right. So we all know that we need to train those models with very specific knowledge, a lot of domain knowledge, so that the answers a Copilot can create are not hallucinating, and you can rely on what the AI is bringing up as results. For years we have focused on supporting engineers with innovative solutions, data, methods to streamline and simplify their daily tasks. And I think AI takes this even a step further, enabling us to develop tools that reduce manual work, automate repetitive tasks, as said, and make engineering workforce more efficient than ever before. We rely on a strong team, so also for Eplan this is not a new thing. We rely on a strong team of experienced AI experts who develop data-driven and scalable solutions for automation and engineering. With deep expertise in software integrations and cloud technologies, we are creating intelligent applications that seamlessly integrate into existing systems. As pioneers in the automation of design and development processes, we actively shape the progress, practical, future-proof, and efficient. We are taking care about this since 2018. So in 2018, we founded a team which was at that time called AIDA, Artificial Intelligence and Data Analytics department, that has been working on the analysis and validation of engineering data, machine learning, and the use of AI models in the context of engineering solutions for automation technology. We are also intensively exploring the advancement possibilities of generative AI, of course. And I will show you some of the examples later on. At the same time, with our EPLAN cloud development and the opportunity it offers, we are creating the necessary solutions and making them available to customers. As a result, we are currently developing solutions that are not only technically advanced and taking advantage of the new technologies, but also offer our customers new, really tangible benefits. So, what are we really working on? How is the situation today, and where should we start with EPLAN, and where do we want to end up? You know, today engineers are still faced with a great deal of manual work and many decisions, as I have described before. This is exactly where AI can offer significant support. And at EPLAN, we are focusing on key areas where we believe AI can make a real difference. Let me give you a quick update on where we are currently stand. We have identified core cases, and one you can see already here. I will talk to this a little bit. Core cases, such as AI-based knowledge acquisition, automated 3D panel layout, and a selection guide for enclosures as major levers for increased efficiency and quality in engineering. So let me start with the EPLAN Copilot. So you can see it's integrated already in our Surface. It's not available yet, but it will become available, parts of it, by the end of the year. This was a showcase that we have been presenting at Hannover Fair this year in April, in collaboration together with Microsoft, using their OpenAI service being integrated into our cloud. And what we wanted to show here is a real practical example of what AI can do. And in this example, what we did is, you imagine you just take a bill of material from your customer, and you want to provide a first offer or a first 3D view on how a design or how a cabinet can look like based out of a certain bill of material. So what we did is we took a bill of material which was just a blank list of components. We matched them against the data portal, got all the dimensions back from these parts, and built a 3D panel layout out of this information. So first arrange them on a certain size of mounting plate, and then generated a 3D model out of this. And you can see this in the middle here of this picture, with all the DIN rails and everything. So it's a little bit of magic, but on the other hand, you know, it's still just the beginning. We were using AI in that case, but the model generated is also based on rules, because AI can't do this magic at the moment. But we are pretty sure that in a short period of time this will be available, and we can work with even more precisely. And out of the same use case, you know, this kind of pre-selection of a fitting enclosure, so the right size of an enclosure, was derived out of this model. So this is one of the, I think, very nice use cases where you can see a practical efficiency gain when using AI. The second one, I think, that was pretty interesting to see is the one that we did together with Siemens. And this is a totally different thing. It's not within the EPLAN platform doing some nice stuff within the engineering process. This has been done to close the gap across processes and perhaps even across companies, but at least here across different system environments. So for those of you who are working with the Siemens PLCs and Siemens controllers, know there is a huge software world also connected with it. It's true for every, I think, PLC and controller manufacturer. And what we have been showing here that, if you're changing your hardware design on the Siemens side, so in this example here, the PLC was exchanged by a newer one. This should be done subsequently also in the circuit diagram, right? So within EPLAN. So today, those two people who are working in this environment, or at least two people working in these environments, have to talk to each other. And there needs to be a change process in place. If somebody changes something on the one side, you have to change it on the other side as well. And by using this agentic AI approach over here, we connected those systems to do this automatically. So first, the agent did the change on the Siemens side, and then was through the orchestra agent talking to the EPLAN agent and say, can you do this for me also on the EPLAN side, fully automatically and fully autonomously. And I think this is where we should be looking at when we think about where do we want to really achieve high efficiency gains by using AI. I think these two cases are showing you pretty clearly where it can help. So on the one hand, by generating certain, I would say, deliverables out of the engineering process, we can even imagine generating circuit diagrams automatically. We can do this today already for those of you who are very deep into it and using our engineering automation solutions. We can do this already today. We have customers having saved more than 90% of their time, engineering time, by automating the whole engineering process. But this is very much rule-based. You have to spend a lot of time and a lot of effort into defining those rules and all the connections between those rules and so on and so forth, but you can do this. And this is where we think AI can help tremendously by not being tied into a lot of work into defining those rules, but let the AI finding the rules, because we can show the AI a lot of results and then make it generating some of the deliverables from the engineering process automatically. And even connect, and this is the agentic AI approach, and even connect to different other systems by using this, the language that is interpretable between the different systems. Like a large language model can today translate English into Japanese, into German, into basically every language around the world. It can also translate this into a programming language. Programming languages are not different to natural languages. So it's a very interesting case where we can see a lot of benefits. And of course, we are also using AI internally to generate code. But the funny thing, frankly speaking, is by generating code, this is like translating languages into each other. It's good and it's interesting. But as I think most of you know, good software does not come from good coding. It comes from good requirements. And this is exactly where AI is not helping today a bit. In defining the right requirements. This is where you have to listen to customers and where you have to describe problems that need to be solved. It's not about coding. In coding, of course, we get a lot of efficiency gains, and this is nice, but the software is not getting better by this. It's only getting better by humans listen to humans and finding the problems that need to be solved and describing those problems in the right and proper way. I can see AI helping in this process, but we're not there yet. But this would be the final, the final step, or the real step, where intelligence would also deliver intelligent solutions. And intelligence is defined by the ability to solve problems autonomously. And this is what it's all about. But then you have to define the problem. And in the end, a machine never in itself has a problem. It solves our problems. And still, so we have to describe the problem in the right way, and then the solution might be there much more efficiently than we used to have it. So this is where we are heading to. This is what we are doing at the moment. And let me close my talk a little bit on why this combination, I think we talked about it also already a little bit, hard and software is so interesting, and why we are taking care so much in our group of companies here. Even though it's not directly connected, you can see it. We are taking care a lot about how to implement those technologies into software, because at the end it's a software game. But the software is nothing without the computational power and the hardware behind it to let it run. And this is where Rittal comes into play. And you might know or might not know that Rittal is one of the key suppliers to these big tech companies running those big data centers, making AI available to every one of us. So like Microsoft, Google, Azure, and so on. And this is where we're looking into. So there's a lot of technology being provided also by Rittal. If you think about direct liquid chip cooling, so it's like your kids might have it at home in their computers. There's also liquid cooling already available to the high-performance gaming PCs. And you can imagine being this the same, but in a pretty large scale. So think about one rack. And this is really one rack, a bit bigger than this steel here, producing 1 megawatt in cooling power. So this is pretty amazing. Looks more like a brewery than a cooler. And this is where we are combining those things. So on the one hand side, Eplan as a software provider, we are taking care of implementing AI cases into the software, making them available to you and everybody who's interested in electrical design. And on the other hand, Rittal is taking care of enabling all those big players in the back end to run those super computers on large scale and limited space. So this is, as I wrap up, I hope you now have a clearer understanding of where we stand at Eplan and what we are working on, and most importantly, what we are aiming to. I think our experts estimate that this approach can save up to 40% of engineering time in near future, and up to 90% in perhaps 5 years from now. So this is where we are really heading to, and I think you are embarking on the right way by working together with us. And the last thing I want to say here is thank you for your trust, thank you for letting me speak here and being a partner to us, and we are trying our best to be a good partner to you. So thank you very much and have a great day.